Hi guys, this is Saturday and the second video of this gadget that we are going to design together. Think about it. You got an Airbnb or in a hotel room. You have your luggage, your belongings, and you want to leave the hotel for some hours. You don't know if someone is going to touch your things or no. In another scenario, you have some things in your drawer in your office and you want to know if someone is trying to reach to them or no. Another example, in your home, you have some things that you said, okay, kid, you shouldn't touch this, or I don't know, these kind of scenarios that you want to understand if someone touches your belongings. Or you want to turn your window to a notification system or door or anything. The device that we are talking about is going to be something like this size, or as I hope, we can go with this size. I hope we can make it this thin, because if you are going to, and it is so cute, uh, because if you are going to attach this to a window, to a door, or to anything, to your book, you are reading a book, you want to know if someone is touching your book. It should be thin. So this will be the overall look of the gadget that we are going to design. So we are going to design a gadget that will turn everything to a notification system. It can be a drawer, it can be your luggage, it can be anything. And the size will be something like this, or hopefully something like this. Believe me, I'm aware of the systems that are already out there. Let's take a look at them together. Okay, for all of the scenarios that we talk about, there are some solutions. For example, we can use a camera, a really cheap, high-quality TP-Link camera called Topo. I use that for many years, and I'm really happy with it. But actually, you cannot put a camera in your hotel room that you are going to stay for 2 days, or you cannot. I don't prefer to use a camera in my bedroom, or I don't know, even in my office. It doesn't feel like trust. So for me, it will not work. There are some trackers. You can track the devices. It is really good. For example, Tractive is a really well-known brand in pet trackers. Okay, they have GPS, they use GSM to send the data, and some of them has accelerometer, but they are big, and they didn't design these devices for this kind of use case. So this is not what we are going to use. And also there are tags, Galaxy Smart Tag from Samsung, and of course AirTag from Apple. It seems really good and suitable for the thing that we are going to use, but no. AirTag has accelerometer sensor which can understand the movement of itself, but it will not send the notification based on the movement. So why they used an accelerometer inside the device? It is just to save the power. So it is using the accelerometer to understand if the device is not moving, put it on sleep mode for longer time. So the interval of sending the data will be longer to save the battery. It will not send any notification based on that accelerometer sensor. So this is off the table for us, but I really love this device and I have used it for a long time. It is really lovely, but not for our case. Let's design something that will fit into this box, or as I hope, we can make it this thin so we can use it everywhere. Okay, now let's talk about the different blocks of this device. So we can start deciding about the material, about the elements that we are going to use, about the components of the electronic side of the device. First of all, as any other device, we need a controller, CPU, microcontroller, or anything that you want to name it. I will just simply write, let's say, controller. it will control the things. We need something to sense that movement. So a sensor. We need a link to send the data. When the movement happened, it should be able to send a notification. So we need a, let's call it connectivity. Of course, we should think about the power. It will have a battery. It should have a battery. So which kind of battery? Is it going to be rechargeable, or is it going to be like AirTag or a smart tag with that coin batteries? Power. And what else do we need? There is a controller. It will connect with something, Bluetooth SIM card, Wi-Fi, something to send the data. There is a sensor. Many different types of sensor are there. We will decide about this. We will sense the movement, analyze it, and send the notification. We have power for that. We need something to make the user able to interact with the device. Like if there is some LEDs or some switches, don't have space there. Let's call it HMI, Human Machine Interface. This is a big word for this device, but right now I don't have anything else in my mind. So this HMI is basically some LEDs or buttons or something like that that we are going to use. Okay, let's decide about every single of these things. The goal is to make the device cheap and also reliable and small. It should be small. It should be thin and small because we are going to use it in different places. That it should be somehow hidden. First of all, connectivity. If we use Bluetooth, like what AirTag and Galaxy Smart Tag are doing, we should rely on the devices around the core tag. So if there isn't any device around that, it will not be able to send the notification. And to be realistic, we are not Apple and we are not Samsung, so we don't have access to that big, huge connectivity network of all the Samsung Galaxy or iPhones or Apple devices. So if we are going to use Bluetooth, there should be devices with our application around core tag. It will be useless. There are two more options. We can use GSM with a SIM card, use internet, 2G, 3G, 4G, doesn't matter, to send the data. That's a good idea, but it will be large. And also, the use cases of this device, at least the use cases that I said, they are in an environment that always we have Wi-Fi. Like if it's a hotel room, if it's an office, if it's a home, we are going to have Wi-Fi there. So we don't have to use, it's not outdoor, and we don't have to use a SIM card to access internet. So I believe that the most logical thing for the connectivity is Wi-Fi. So let's change the connectivity to Wi-Fi. About the sensor, there are different ways to understand the movement. There are some sensors that will understand the vibration. There is a pipe inside that. There is a small spring. Pipe, spring, vibration sensor. I don't know the name of that, but let's see. something like these things, but really small. About the sensor, we need a sensor to be really low power and be able to wake up our microcontroller. So the microcontroller is not going to read the sensor continuously. It will just go to deep sleep mode. And whenever the movement happens, the sensor will wake the microcontroller up. Uh, Obviously, we are going to use an accelerometer, because if we use something mechanical, it is not easy to configure it to make, for example, I want it to be configurable. I want it to be, for example, mm, how to put it together? If someone wants to open a drawer, try to open the drawer, will shake it, and if the drawer is open, just pushing it, there is no shake. It's just a movement. So a normal spring sensor cannot detect it. We need something to measure the g-force of the movement. And with that g-force, we can understand if there is a movement, if there is a vibration, we can define the type of the movement, in which vector the movement happens, x, y, z. So the accelerometer is the best option. And about the power, I really prefer to make it rechargeable, because I will not be able to make it as power efficient as something like AirTag. So I don't want to ask user to change the battery every week or even every month. It's not logical. So we need let's add something here. If we are going to use a rechargeable battery, we need a charger and the battery. For the battery, it should be small. We cannot go with lithium ion, because they are bigger than lithium polymers. We need something thin and small with high capacity. So with the options that we have now, it will be a lithium polymer or LiPo battery. I believe that it will be something around 100 milliamps per hour. Uh, I don't know. Let's see what we can find in the market, but it should be really small. And the charger, it should be the smallest charger circuit that we can find on the market, because if the battery is that small, for example, if it's a 100 milliamps battery, we cannot charge it with 1 amp. We should charge it with what, 100 milliamps max, to not damage the battery. So and also the dimension is matter here. It should be the smallest charger that we can find. So charger will be smallest LiPo, or let's say lithium polymer and lithium ion chargers are almost same or identically same. I don't know. Charger smallest lithium charger. And HMI. About this, anything with the charger need an LED to show that the power is connected, and LED to show the battery is charging or full charged. And also we need another LED to show the status of the device. That for that purpose, one LED is enough, I think, because we can make it blink fast, blink slow, solid on, solid off, to show 4 different status of the device. So let's go with 3 LEDs. We will use 3 different colors to make it easy for the user to understand what's going on with the device. We need the on-off button, of course. This slide switches, because if it's always on, when you are moving it around to put it somewhere, it will constantly send you notification. Or even if you put a interval for that, with an interval, you will always getting notifications. So we should be able to turn it off and turn it on when we want to put it there and start using it. And on off button. And there will be some configurations, I believe. We have Wi-Fi, so we should be able to enter the Wi-Fi credentials, like the device should scan for Wi-Fi networks for Wi-Fi networks, and the user will select one of them, enter the password to be able to connect to that Wi-Fi network. So we should be able to switch to that mode, configuration mode. And also about the accelerometer, I want it to be configurable, so we can make it really sensitive or less sensitive based on the use case. So I will put a switch, let's say config switch. So if the user hold this switch or just press this switch, we'll decide about it later, the device will switch to the configuration mode to be able to configure the parameters. About the controller, because the price is really important, I'm not sure if we are going to use an STM32 or an ESP32. Because we are going to use Wi-Fi, I believe that ESP32 is the logical option. It is cheap, and also it has built-in Wi-Fi connectivity. If we go with STM32, the SoCs of STM32, which have the connectivity, Wi-Fi connectivity option, they are really expensive comparing to ESP32. And ESP32 have different variants that we can just switch to a cheaper one. And yes, that's it. Next thing that we should do is the part numbers, deciding about the part numbers. I believe that I'm not sure if we can do that today or it will be the other day. I will try to. My laptop battery is almost finished. If I can find a plug, I will continue and decide about the part numbers. If I couldn't find a plug, that's it for today. And cheers.